Welcome back to my channel. I'm Brian Kafferkey, and this is the fourth video in the series called Python Programming for Beginners, Variables as Objects. So let's jump in. And before I do, I did want to take a short moment and tell you about a really exciting thing for me, which is a book I've just published. I left Microsoft back in December to write this, so it's been over 9 months that I've been developing this book, working on it. And I think it's a great book and one that was sorely needed, which is why I decided to write it. Databricks is based on Apache Spark. In fact, the way to look at what Databricks is a user-friendly wrapper around the big data service, the open source big data service called Apache Spark. If you've heard of Hadoop MapReduce, this is sort of the next, version 2, I guess you could say. It's the next replacement to that. It runs in real time, it can handle streaming, it does a lot of things that are lacking in Hadoop MapReduce, and so not surprisingly, it's the most popular open source big data platform on the planet. It supports data science, machine learning, and all kinds of big data, massive data, and different data types. It also supports Python, which is why it's relevant to these series, as well as R and Scala and a bunch of languages. Now this may be more advanced than you're ready for, but in case you're trying to advance your skills into the next generation, I believe that Apache Spark is the place to be, and Databricks is the best way to get to Apache Spark. And Azure has a first-class service that I found out about when I was there and just really became obsessed with. So I did a whole video on that, so check that out. This book is a comprehensive resource that takes you through from beginner to expert so that you can really learn how to master this tool. And it uses a use case to step you through from, the company wants to do this, here's how we start getting the data together, here's how we clean it up, here's how we scale and blah, 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 and do things. And so it can also be used by experts, I should point out, though, for reference, because it is organized by topical area, and it gets into details and very not often talked about features and services kind of under the covers that I get into. It's available on Amazon, so please buy a copy. And if you do and you like it, do a survey feedback on that, because reviews help get it noticed. So back to our story. And by the way, I'm drinking out of my Star Trek Federation mug that I got when I visited Starfleet Academy in San Francisco a couple of years ago. Now Starfleet Academy is cloaked, so you can't find it, and you're going to be careful because you can bump into a building not realizing it's invisible. We're going to talk about objects, why you care what they are and what they are. We're going to talk about understanding variables as objects and the fact that they really are objects. We'll look at object methods and properties. And we'll look at using variable object methods and properties specifically. This is something I really want to emphasize, and that is that methods and properties of objects is this sort of pattern that is throughout Python. Because Python is primarily used as an object-oriented language, so I want to bring you into this as early as possible. This is very early in the stage of learning Python that I'm introducing this idea, but I think you're smart enough and capable enough of picking it up, and actually it's not that hard. It's easier than not doing objects, and that's why I want to introduce it as well. And then I'll wrap things up. So I'm going to start with a simple English sentence, hopefully you know English, and then explain how this relates to object-oriented programming. So let's look at the sentence. Fluffy, the Cocker Spaniel dog, chased the ball. Let's break this down. The dog is a type of object, right? I think we can agree on that. And dogs have certain characteristics. That's how we came up with the word dog. It's actually a class of objects, right? It's a classification. Dogs can do certain things, and they have certain properties. They're hairy, they shed on my couch, whatever. That's what a dog is. And we can see there are characteristics of a dog. For instance, we have a breed. There's a color of the dog. There's a weight, there's an age, etc. We also have things that this dog can do. It can chase, it can catch, it can bite, and on different things that the dog can do. Now if we think about it, the type of thing a dog in the broad sense is a type of object, but not a specific one. A specific example of a dog would be Fluffy, my dog. That's an instance of a dog. We can have the neighbor's dog, Fido, and that's another dog. So those are called, in object-oriented programming terms, instances. And the descriptors we saw here, I revealed this a little too soon, but the adjectives that describe an instance are called properties. So these are properties. The name of my dog is Fluffy. The name of the neighbors is Fido. But they're both instances of a class dog. All right. I think that gets the best. And when we think about the verbs or actions that dogs can do, or any given object type can do, those are called methods. That's about it. So we've got a type of object. We have instances of that type, which are the real objects in the world. And then we have descriptive items about them, which are properties, and then things they can do, methods. Let's walk through this real quickly again. Object type dog. We talk about object type. We typically, in programming terms, would call it a class as opposed to object type. Depends how you're doing it. When you're actually in the language of programming, you would say, I'm going to instantiate the class A to create an object or an instance of the object. But when you're describing, you may also call it an object type. We have methods that we talked about. It can bark, roll over, eat, drink, and do any kinds of things we can think of. And of course, there's properties like this is Fido, this is a Cocker Spaniel, this is a female, etc. Now, to take this to another direction, because you know I like Star Trek so much, I brought in a model of the Starship Enterprise. And you can see here, this has both methods and properties. The properties, for instance, NCC 1701. There are many different versions of the series in Star Trek of Enterprise. They all have the NCC 1701, but then you'll start to see A, B, C, D, E as the franchise advances. They're all called Enterprise. Now actually there's a bunch. This is an instance of a certain type of starship, a Constellation class, I believe was what this one was. But there was also the Hood, the Yamato, and a bunch of other ships of this type at that time. And so you could argue the Enterprise is really an instance of that class. And in addition to properties, it has methods. That's going to warp. And that's firing photon torpedoes. That's just weird sounds that you heard on the bridge and nobody knows why. And that's firing phasers. So we can see it has methods and properties. And I also have, if you thought I didn't, you were wrong. In case I need to get hold of a starship soon and get beamed up, I have a communicator. It's hard to flip it, but I'm getting the hang of it. And this can make a weird sound that I don't really know what it does. I think it's supposed to explode when you do that too long. It can light up a red light, and I can call the ship and get beamed up. So it has very few properties other than the fact it's black and gold, etc. And methods like calling the Enterprise. So kind of examples of all things around us. I do want to step back and say, if you're thinking about you were writing a program, let's imagine you're writing a video. It might be, for instance, a video game with Star Trek in it, right? Or it might be a video game with a dog. From a programming standpoint, wouldn't it make sense if you could create sort of standalone programs that actually acted like physical objects? So could I, for instance, in a video game, have a program that I would actually call out an object, like a starship, and I could then do things like, say, fire phasers and move and do this. Or have a dog that pops up in a game and moves around. Well, that's actually the idea behind object-oriented programming, is the idea that we can create something that it hopefully resembles something in the real world, and then we can actually treat it as an object. It's a program. That's what a class is. It's actually a program. But we've organized that program with data called properties and actions it can do called methods, so we can use it. And it creates a nice insulation we call encapsulation. It encapsulates everything we need in a dog, but it keeps it out of our main code, right? We don't have to worry about it. Once somebody wrote a good dog, we don't have to worry about mucking with the dog anymore, or their Enterprise, or whatever it is, the starships. And that's the idea. This was a brilliant breakthrough. I started before they had object-oriented programming, and let me tell you, it was messy. It wasn't fun. You guys are lucky. Object orientation was a huge advancement. You may have seen this already in different things you've done, because you may have, for instance, been working in Excel, and you might have to deal with a printer object. Typically, printer objects are actually implemented as programs, which are objects or classes. And that's really nice because internally, say Windows can do things like set the fonts and tell it to print methods and do all these different things. And internally, it has different instances, right? All the printers you have are instances of a printer object that can be manipulated and used. So this idea of really conceptualizing this way is useful because it lets programmers think of things in their program the same way they do in the real world, makes things easier. So let's take this idea now and bring it to our code. My last video I talked about using variables, and I showed you the different types. This code, we have two variables being created in the first two lines, first underscore name, and we're assigning it to, in quotes, Brian. That's going to be a string because it's text. We call that a string. What type of object is it? It's a string object. It's actually coming from the string class, and we're going to get an instance. And don't worry about all the terms. I know I'm using all these different terms, but get the idea. Most importantly is that you're going to have an object, that your variable is an object, that almost anything, in fact, I'll say anything for now, that you create in Python is an object and has this ability to have properties and methods. You don't really need to worry about any more than that, but I figure I might as well give you the correct terms so you sound smart at your cocktail parties when you're trying to impress people. All right, so we have a string here. Now we're assigning age equal 30. Now notice we're not telling Python what to call these objects. Like, we're not telling it it's a string or it's this type of object. Python was designed to make life easier for you, so it uses something called dynamic typing, or IntelliTyping, you might almost call it. It sees that you put quotes around something and gave it a value. It says you want a string. Here it's saying you said age is 30 and I don't see a decimal point. You want an integer, meaning a whole number. But in this one, wait, you said 145.5. It says, oh, you must need a decimal. And the type of object I create for a decimal is a float. So you get a float. And this one I'm saying is minor equal false. This is a bool, which is short for Boolean, which is either really 0 or 1. Internally in computers, the entire thing, which is scary, is all just working with zeros and ones, and somehow that turns into programs, which is kind of magic. So when you look at Booleans or bools, it's really showing you true or false, but behind the covers it's really like zeros and ones. Go figure. And then we've got print statements here that are giving us the type as well as the name of each variable. And we can see that output below. So we can see first name is a class string. Wow, class, right? Gets back to it. It is a class. Python's really weird. We could actually go to the source code, the code that defines these classes, because Python gives you everything. There's also an age, int, class, right? Class int and class float. So these are types. We could have many strings and many age variables, etc., int variables. So those are classes or object types. Everything is an object. Again, this is why it's so important, because you're going to see this over and over again. So if you get used to this concept with variables, you're really well set for a lot of other things to come, which makes Python a really exciting language. So let's walk through an example. Here we're saying name equal Brian Cafferkey. This object type, as we talked about, is a string. And the instance is the name. We're given one instance of an object type or class string. It has methods. Now these are actual methods. We can do a find. So if we wanted to find, for instance, all the letter A's in it, we can say find and then in single quotes A, and it will find them. Replace, maybe we want to replace all the A's with an X, we can do that. Or we could say split it, wherever you see a space. So you might have a lot of different words and you want to get them back as, say, a list. We'll talk about what that is, but break it into multiple words, and split can do that. Pay attention to one thing, syntax. Talked about that, a whole video just on syntax, but the parentheses. When you use methods, you will always see parentheses. And the idea behind the parentheses is you can pass parameters in those parentheses, but whether or not it even takes parameters or whatever, it still needs the parentheses, a beginning and ending. If you don't get it, you'll get a syntax error, and that's why. You also have properties, and properties also have the parentheses. Now, count probably isn't really a property, it's more of a method, but there aren't many properties for a string, so I wanted to show it there. Is numeric, I think, is arguably a property. But the idea with property is it's that idea that it's some sort of descriptive thing. It's something that describes this object. Here we are in a Jupyter Notebook. Another video I'll put at the end of this is a video I did all about Jupyter Notebooks, why they're cool, why they're fun. I know some people don't like them, but try to, if you're a programmer before, try to get away from the idea that you're here to build something and you know what it is. Jupyter Notebooks are more for exploring. And one of the nice things you can see is we can give nice descriptive information. So they're meant to also share with other people. Now, I do my video, but just so you know, we can run everything in Jupyter Notebooks is in little blocks we call cells. These are markdown cells, which mean they're meant for documenting what we're doing. And I use them here because they're really nice for when you're doing training like this. So as we've seen a couple of times now, I'm going to create a variable name, and I'm going to assign it the Brian Kafkian quotes. And I'm doing Shift-Enter to just advance to the next cell after I run. Now, one of the things I can do is I can enter the name, period, hit Tab, and this is really cool because it's kind of like IntelliSense you might have seen in like Microsoft Visual Studio or something. It's going to give us a list of all the objects and properties available on this type of object. So this has all these things available. It can split, it can check, is it alpha, is it numeric, all these different things. Very cool. So if we want to know one, we could pick one like lower, and it just puts it in for us. But remember, we will need this to do it. And we can do that, for instance. The other thing we can do, though, is we can do period. I think it's Shift-Tab. And Shift-Tab will tell us the type of object. So it tells us it's a string, that the value is, and the length. So that's kind of a nifty thing, too. And if we wanted to, we can do period, say lower again. So, and say I want to do capitalize, but I don't know much about this function. I can enter a question mark, oops, and then run the cell, and we get this little pop-up that gives me information about the function. Now there's other ways to get help. You got the help thing over here and stuff, but these are ways you can get help on what you're doing. So let's try this method to get the title. And what it does is title will capitalize the first letter of each word. So it's useful if you have a string and you know it's a name, but maybe people didn't consistently capitalize the words. So you can get like John Smith, Mary Doe, etc. That's the idea behind it. And when you work with data, if you've worked with it long enough, you will find out nothing's consistent. That's the rule of data. Okay, we can see also that though I used the title method and it did this wonderful capitalization, it didn't change. See, the C is still lowercase there. Did not change my original variable. Why? Because Python variables, confusingly, are said to be immutable. What it really means is when we use methods and things, you cannot update a variable. At least this particular variable, a string variable, cannot be, it's not mutable. Some things are mutable, so I should be careful how I say that. But a string is not. But it really becomes a bit unimportant when you're coding, other than to know that there's some nuances when you want to reassign a value. When you want to reassign a value to a variable, which I'll show you in a minute, you need to essentially destroy and crush it and build a new one. That's what's happening behind the scenes. You don't just edit it in place, you might say. So we can see the name still there. So some other things we can do, name underscore upper, will make the entire string uppercase. Here I'm going to do a count of all the letters A. Got 2 of them. Here I'm going to assume this is a property and say, is it numeric? Meaning, does this string consist all of letters and or numbers, I should say? And it's no, it's not numeric. And I wanted this one split, means give me back the individual words because I'm separating it by space. And you can see we got back 2 separate words. This is something called a list it gave back, which we'll learn about later, but it broke it up. I can say find AN in the string, and it said 3. Spoiler alert, strings start with a count of 0. They call that an index. It begins at 0. So so here we're saying it found AN at 0, 1, 2, 3. It's really the 4th character. So just be aware of that. We can replace something like A with X. You can see it did that. All right, sorry. Did that here. And again, did not change our original string. If we wanted to change the original string, first we could either give a new variable and have the return value. When we're doing these methods, it's actually giving something back. If we don't put it anywhere, Jupyter just displays it to us. Most of the IDEs wouldn't even do that. It would just do it. It may or may not display it depending on the IDE you're using, the development environment. But here we're saying replace, and it's going to return it into this variable new name, and then we'll just display new name, and you can say it did this. New name now has that value. All right, so that's what's going on there. Now you may say, well, what if I want to replace the actual name? I want to just change the variable I have right where it is. Well, the way to do that is just say name equal, and then this will return that. And that's why I said that's where it's going to really just delete the old one and give you a new one, essentially. And there it is. And now it's changed. A couple of little things before we leave. The alternative way to work with something like a string is to use functions. Functions are not attached to objects. So they're like methods, but they just work on whatever you happen to pass into them. They're generic, you might say. So here I'm using the length function to get the length of name. And I could pass many other things into length and it will return a result. So again, it's not attached. It's a function that is not attached to an object. So it's not called a method typically, it would be called a function. Now I didn't talk about other things. For the numeric variables, there's not much value here, but I'll do what I can. Balance, for instance, equal 250, and I can say, is that an integer? It says true. It said true because there's no decimal part. But imagine if I changed this and said 50 cents. Change the value, and now it says false. It's not an integer. So that's kind of a nice way we can easily check a variable with a method. And you can see here that the value is what it was. Here I'm going to put an integer into age, 35, and there really isn't much I can do with integers, but I can give you the bit length, and if you find that useful, good for you. But that's about it. So these are different ways we can use methods and properties, and again, it's a very broad pattern you're going to see over and over and over again in Python, so now you know it, and you're ready to have some fascinating conversations at cocktail parties. So using Python variables, kind of a quick refresher, we just did this. We see here name equal Brian Cafferty again, and we can see us using the capitalize method to capitalize the first letter of the first of the word, and then we can see, actually that should have two words, but that's a little bit of an error, and then upper converts the entire thing to uppercase. So the first one must be a legacy thing. I left something there. It should say Brian Cafferty, both words. The second one shows it spelled out. So don't get confused. We have the object, we have the method, and a period between them. And don't forget the parentheses. So wrapping up, we talked about objects. I showed you my really cool spaceship and my communicator, and showed you I'm a Star Trek nerd. We also talked about Fluffy, my dog, and the fact that Fluffy has properties like a Cocker Spaniel and brown and weight and etc., as well as methods. Fluffy barks, Fluffy does many things. Sometimes does a method on the couch, which means I have to clean it up. So there's lots of things Fluffy can do. So that's our idea of objects. We now understand the objects. We wanted to apply that to variables, and we learned that variables are in fact objects. And we learned that the object type is also called a class, and when we create something like a string or an int, that is actually instantiating an instance of a string or int class. We looked at using object methods and properties, and we walked through a Jupyter Notebook example. We used different ones, and I showed you how you can put the period and then tab, and you get a list of methods and properties available. So it's kind of a cool place where you don't even have to really search anywhere to get more information, and most of the time the properties are fairly intuitive, like, oh, count, that sounds useful. So that's a really nice way to use these things. So we talked about a lot. I mentioned my book, so please, if you're interested at all in getting into the big data world and data science and all that riveting stuff, look at my book and share and let people know about it. I hope you like this video. I'm going to keep doing the training on Python, the basic beginning, and please let people know about this as well, because I think it's a good way to kind of get people into the world of programming, and hopefully it's useful. I like the comments, I read them, and yes, please like, share. When you subscribe, make sure you click on the bell icons, because that will allow you to get notifications and you'll see when I'm doing more videos. Thank you.